January 17, 1940. Somewhere in the English Midlands, the workshop smelled of burnt metal and diesel fuel. Snow pressed against the frosted windows while inside, under a ceiling of exposed beams and flickering industrial lamps, a man stood before a pile of scrap that others had deemed worthless. His name was Percy Hobart, though the men who worked under him had other names for him, names whispered in barracks and shouted across parade grounds. Hobo, the lunatic, that mad bastard with the tanks. He wore no expression as he surveyed the wreckage before him, twisted steel plates from a lorry collision, the gutted chassis of a civilian tractor, sections of railway track destined for salvage, and the skeletal remains of a Morris truck that had been condemned 3 months prior. Behind him, a young lieutenant shifted his weight nervously, clutching a clipboard that bore the impossible directive from command. 36 hours. That was all the time they had. 36 hours to produce something, anything that could move, fire, and survive contact with an enemy that had just demonstrated its mastery of mechanized warfare across Poland. The lieutenant cleared his throat. Hobart did not turn around. He simply reached into his coat pocket, withdrew a crumpled cigarette, and lit it with the methodical precision of a man who had already begun calculating angles, weights, and the tensile strength of desperation. The year 1940 had arrived not with celebration but with dread. Across the Channel, the German Wehrmacht had shattered every assumption about modern warfare. Poland had fallen in 27 days. The Panzer divisions had carved through defensive lines that were supposed to hold for months, their coordinated attacks revealing a doctrine that married speed, firepower, and shock in ways that made the trenches of the Great War seem like ancient history. Britain watched. Britain counted its tanks, machines that were too slow, too lightly armored, too few. The factories were ramping up production, but production took time, and time was a luxury measured in the heartbeats of a continent holding its breath. The High Command issued directives, training programs were accelerated, reservists were called up, and in workshops scattered across the industrial heartland, engineers were told to perform miracles with whatever materials could be scraped together. Percy Hobart had been recalled to active service after a forced retirement that had nearly broken him. His theories on armored warfare had been too radical, his temperament too abrasive, his willingness to challenge superior officers too frequent. He had been pushed aside, labeled difficult, consigned to the home guard where his expertise would rust alongside the obsolete equipment he was given to command. But war has a way of rehabilitating the inconvenient. When the need for armor became desperate, when conventional thinking proved inadequate to the threat bearing down from the east, someone remembered the lunatic who had been right all along. The directive was absurd on its face. Construct a functional tank in 36 hours using only salvaged materials and whatever could be requisitioned from civilian sources without formal authorization. No blueprints, no factory support, no proper armor plating or precision machined components. It was a test, perhaps, or a punishment disguised as an opportunity. Hobart had read the order 3 times, his weathered face betraying nothing before folding the paper and placing it in his pocket. Then he had made a list, not of materials, those would reveal themselves, but of principles. A tank stripped to its essence was a mobile gun platform protected by armor and powered by an engine. Everything else was refinement. If you could move it, protect it, and make it shoot, you had something that could at least delay an enemy advance long enough for proper reinforcements to arrive. That was the logic of desperation, the mathematics of buying time with ingenuity when steel was in short supply. He assembled his team not from engineers but from mechanics, welders, and men who had spent their lives making broken things work again, farm equipment repairmen, dockyard fabricators, a former circus rigger who understood load distribution and improvised structures. These were not men accustomed to military precision, but they understood materials in a way that no academy could teach. They knew what metal could bear, what welds would hold under stress, what shortcuts would fail catastrophically, and which ones might just work long enough to matter. The first 12 hours were spent in ruthless assessment. Every piece of scrap was examined, measured, tested. The tractor chassis became the foundation, solid, over-engineered for agricultural work, heavy enough to support additional weight. The railway tracks were cut and shaped into improvised armor plates, their hardened steel capable of deflecting small arms fire if angled correctly. The Morris truck surrendered its engine, a four-cylinder petrol motor that was underpowered for a combat vehicle but available, functional, and simple enough to maintain under field conditions. Hobart moved among the workers like a ghost, appearing at a welding station to adjust an angle, kneeling beside a transmission assembly to verify clearances, disappearing into the shadows only to emerge with another component salvaged from the boneyard of British industry. He spoke rarely, but when he did, men listened. Not because of his rank, many of them barely recognized military hierarchy, but because his instructions carried the weight of certainty. He knew what would work because he had spent years thinking about what wouldn't, years studying the failures of the last war and the innovations of armies that had learned faster than his own. There was no romanticism in his approach, no attachment to tradition or aesthetics. The machine taking shape under the workshop lights was ugly, asymmetrical, a Frankenstein's monster of improvised warfare. But it was also becoming real. By hour 18, the basic structure existed. The tractor chassis supported a welded frame reinforced with railway steel. The engine was mounted, connected to a transmission that had been cannibalized from two separate vehicles and married together with custom machined adapters fashioned from solid bar stock. The tracks, genuine tank tracks, salvaged from a training vehicle that had thrown a sprocket and been written off, were fitted and tensioned. The thing could move, slowly, grinding, belching black smoke from an exhaust system that was little more than a pipe welded to the manifold, but it moved. The crew celebrated with tea and cigarettes, their faces blackened with grease, their hands wrapped in filthy rags to protect burns from welding spatter. Hobart did not join them. He stood outside in the January cold, staring at the workshop doors, calculating what remained. Movement was solved. Protection was partially addressed. But a tank without a gun was merely a target, and targets did not change the outcome of battles. He returned inside and walked to the far corner of the workshop, where a stack of wooden crates had been pushed against the wall. Inside those crates were Vickers machine guns, .303 caliber, veterans of the previous war, stored in Cosmoline and largely forgotten. They were not artillery. They would not penetrate modern tank armor, but they could suppress infantry, destroy soft vehicles, and provide covering fire. Most importantly, they existed, and existence was the primary qualification for inclusion in this project. The mounting system was improvised from pipe fittings and steel plate, creating a simple ball mount that allowed traverse and elevation. There was no sophisticated targeting system, no rangefinder or ballistic computer. The gunner would aim by looking along the barrel and adjusting based on observed impacts, exactly as infantry had done for centuries. It was primitive, but primitiveness implied reliability. And reliability might mean the difference between a weapon that fired once and one that fired until its ammunition was exhausted. By hour 24, the gun was installed. Test firing would come later, assuming there was time and a safe place to conduct it. For now, the crew focused on the details that separated a static assembly from a combat vehicle. Ammunition storage was created from welded boxes bolted to the interior frame. Vision ports were cut into the armor, simple slits that provided minimal visibility but at least allowed the crew to see where they were going. A rudimentary communication system was rigged from civilian radio components, the effective range perhaps 2 kilometers under ideal conditions, but better than signal flags. Seating was wooden planks salvaged from shipping pallets. The steering mechanism was direct mechanical linkage to the tracks, requiring significant physical strength to operate. There was no suspension system beyond what the tractor chassis originally provided, meaning that every bump, every dip, every irregularity in terrain would be transmitted directly to the crew's spines. Comfort was not a consideration. Functionality was the only metric that mattered. Hour 30 marked the first complete operational test. The engine roared to life, its unfiltered exhaust filling the workshop with acrid smoke until someone threw open the loading doors. Hobart climbed into the commander's position, a seat that was little more than an ammunition box with a cushion laid across it, and gave the signal to advance. The machine lurched forward, grinding, shaking, every weld and bolt protesting the abuse. It rolled out into the January night, tracks biting into frozen mud, headlamps casting pale light across the testing ground that had been cleared behind the workshop. Left turn, right turn, full stop, reverse. Each command was executed with grinding determination, the driver fighting the steering levers, the transmission screaming in protest, but the machine obeyed. It moved at perhaps 8 kilometers per hour on flat ground, slower over obstacles, but it moved under its own power and carried its gun and crew. Hobart called for the weapons test. The Vickers was loaded. The gunner traversing the mount to aim at a stack of barrels placed 50 meters distant. The command to fire was given. The machine gun stammered, its familiar sound cutting through the night, rounds impacting the barrels and punching through the thin metal. The gun worked. The mount held. The improvised tank had teeth. They returned to the workshop with 6 hours remaining. The final phase was not about functionality but about survivability. The armor plates were reinforced at the joints where welding was weakest. Additional bracing was added to the gun mount to prevent it from tearing loose under sustained fire. The engine compartment was modified to allow faster access for field repairs. Because everyone understood that this machine would break down, the only question was whether it could be fixed quickly enough to matter. Fuel storage was expanded using jerry cans strapped to the exterior, a dangerous solution that made the vehicle more vulnerable to fire, but extended its operational range from 30 kilometers to perhaps 60. Every decision was a compromise between competing necessities, every modification a calculation of acceptable risk. There was no perfect solution, no configuration that optimized all variables. There was only good enough, and good enough was defined by the ticking clock and the knowledge that somewhere across dark water, German factories were producing real tanks in quantities that would darken the fields of France. Hour 35. The crew gathered around their creation, exhausted, filthy, swaying on their feet from lack of sleep. Someone had painted a name on the forward hull in white paint, Hobart's Folly. It was meant as a joke, perhaps, or an acknowledgement of the absurdity they had just completed. Hobart examined the lettering without expression, then produced a small notebook and made several annotations, observations about what had worked, what had nearly failed, which shortcuts could be replicated, and which should never be attempted again. The lieutenant who had delivered the original order returned at hour 36, accompanied by a senior officer from the War Office, a man whose uniform was too clean and whose skepticism was worn like a second skin. They walked around the vehicle slowly, noting every crude weld, every improvised component, every violation of proper engineering standards. The senior officer tapped the armor with his swagger stick, producing a dull clang. He peered through the vision slits, examined the gun mounting, opened the engine compartment, and stared at the tangle of belts and hoses that bore no resemblance to factory specifications. Finally, he turned to Hobart. "Does it run?" he asked. "It does," Hobart replied. "Does it fight?" "That would depend on the enemy." "Can you make more of them?" Hobart lit another cigarette, his eyes never leaving the officer's face. "I can make whatever you're willing to let me build, sir. But understand that what you're looking at is a stopgap, a temporary solution to a permanent problem. If you want real tanks, you need real factories, real materials, real time. If you want something that might slow down a German advance long enough for your infantry to dig in and your artillery to find range, then yes, I can make more of these." The officer nodded slowly, his skepticism not erased but at least tempered by the evidence of what desperation and expertise could accomplish when combined. "How many could you produce in a month?" Hobart glanced at his crew, men who had worked without sleep, who had burned their hands and strained their backs and pushed themselves past reasonable limits because the alternative was unacceptable. "With proper support? 20, maybe 30. They won't win the war, but they might buy time. And time, sir, is the only thing we don't have enough of." What happened in that workshop during those 36 hours was not recorded in the grand narratives of the Second World War. There were no newsreels, no photographs distributed to lift civilian morale, no medals awarded for the creation of Hobart's Folly. The vehicle itself likely never saw combat, probably never left the training ground where it was used to teach other crews the basics of armored operations until proper equipment arrived. But its significance lay not in its operational history, but in what it represented. A defiant rejection of the notion that Britain would surrender its fate to the efficient machines of its enemies. Across the Channel, German engineers worked in state-of-the-art facilities with precision tools, unlimited materials, and the backing of an industrial system designed for war production. Their tanks were masterpieces of mechanical design, products of careful planning and substantial investment. They were superior in every measurable category, armor thickness, gun caliber, engine power, reliability. Yet in a frozen workshop in the English Midlands, a man deemed too difficult for peacetime service had demonstrated that the spirit which built empires did not require factory support or formal authorization. It required only the refusal to accept defeat and the ingenuity to fashion weapons from whatever materials could be scrounged from a nation's industrial cast-offs. The German command, as they planned the coming invasion of France and the Low Countries, calculated their advantages with Prussian precision. They counted tanks, measured fuel reserves, assessed the quality of roads and bridges, and determined with mathematical certainty that their mechanized forces would achieve breakthrough and exploitation faster than the Anglo-French alliance could respond. Their calculations were based on known British tank production, on the inventory of armor available to defend the home islands, on the reasonable assumption that a nation unprepared for war could not suddenly conjure effective weapons from thin air. What they could not calculate, what no intelligence service could quantify, was the effect of 10,000 Percy Hobarts working in workshops across a nation that had decided it would not fall. They could not measure the willingness of skilled workers to labor until collapse, if it meant adding even one more weapon to the arsenal. They could not factor in the cultural memory of a people who had spent centuries improvising solutions to impossible problems, who had built a global empire not through superior numbers, but through superior adaptability. The Germans expected to fight the British army as it existed in manual and regulation. They would instead confront an enemy that rewrote its own rules when the old ones proved inadequate, that discarded doctrine in favor of whatever worked, that treated official channels as suggestions rather than requirements when speed mattered more than procedure. The symbolic power of the folly extended beyond its crude functionality. It was proof that the tools of modern warfare, despite their complexity and cost, could be replicated, however imperfectly, by anyone with knowledge, determination, and access to scrap metal. The mystique of the Panzer divisions rested partly on the assumption that their machines represented a technological advancement that less prepared nations could not match. But Hobart had demonstrated that a tank, reduced to its essential components, was merely an engine, some armor, and a gun. Everything else was optimization, and optimization was a luxury that defenders did not require. Survival demanded only minimum viable lethality, and minimum viability could be achieved with cutting torches and welding equipment in less than 2 days. This was a lesson that would echo through the war in countless forms, the British developing specialized armor variants for specific tactical problems, the Soviets mass-producing T-34s with brutally simplified interiors, the Americans flooding Europe with Shermans that prioritized reliability and numbers over individual superiority. Each represented a different calculation of what constituted good enough, but all shared the foundational insight that perfection was the enemy of availability. And in war, the weapon you have today is infinitely more valuable than the weapon you might build next. Here, the recurring symbol in this narrative was not an object but a mindset, the willingness to see possibility in wreckage, to recognize that the difference between junk and weaponry was merely a question of perspective and application. The pile of scrap that greeted Hobart on that January morning was, to most observers, exactly what it appeared to be: the detritus of industrial civilization, materials that had exhausted their usefulness and awaited recycling into something else. To Hobart, it was a tank that had not yet been assembled, components waiting for someone with sufficient knowledge to recognize their potential configuration. This cognitive reframing was itself a weapon, more powerful in some ways than the vehicle it produced, because it suggested that every warehouse, every scrapyard, every civilian factory could be converted into a source of military capability if necessity demanded it. The Germans could bomb factories, disrupt supply chains, destroy the formal apparatus of British war production. But they could not bomb the knowledge in 10,000 heads, could not destroy the skills accumulated over lifetimes of making and fixing and adapting. As long as there were men like Hobart, and materials like scrap and workshops with tools, the capacity for resistance would persist regardless of how many tank factories were reduced to rubble. Percy Hobart would go on to design specialized armor for the D-Day landings, the Hobart's Funnies, that cleared mines, laid bridges, and provided close support to infantry assaulting fortified beaches. Those vehicles would be recognized as crucial innovations, receiving the official acknowledgement that his earlier work had been denied. But it was in that unnamed workshop during those 36 sleepless hours that the template was established. Not the technical specifications, those were unique to the materials at hand, but the methodology, the philosophy that treated military engineering as problem-solving under constraints rather than the execution of established designs. Every tank he would later create, every modification and adaptation and unconventional solution, traced its lineage back to the moment he stood before a pile of scrap and decided that impossibility was merely an opinion held by those who lacked imagination. The lieutenant who had delivered the original order, who had watched the process unfold with a mixture of horror and fascination, would later write in his diary, "I understood today that we might actually survive this war, not because of our resources or our industrial capacity, but because we have men who refuse to accept that anything is truly impossible. The Germans have better tanks, but we have Hobart, and I suspect that may prove the greater advantage." The machine itself, Hobart's Folly, likely ended its days as training equipment or was scrapped when proper armor arrived in sufficient quantities. No museum preserves it, no memorial plaque marks the workshop where it was built. Its specifications were never standardized, its design never replicated exactly because it was never meant to be a model for mass production. It was a demonstration, a proof of concept, a middle finger raised toward the notion that Britain would wait passively for German armor to cross the Channel because it lacked the proper tools to resist. The value was not in the vehicle, but in what its creation proved about the nation that built it. That ingenuity could partially compensate for industrial shortfall, that expertise could be mobilized as quickly as factories could be converted, that the real arsenal of democracy was not steel and gunpowder, but knowledge and adaptability. The Germans had spent years preparing for war, stockpiling materials, designing weapons, training crews. Britain had spent those years hoping that war could be avoided, delaying rearmament, prioritizing social spending over military preparation. When the moment of crisis arrived, the German advantages seemed overwhelming. Better tanks, more tanks, crews with combat experience, doctrine that had been tested and refined. On paper, the comparison was humiliating. But wars are not fought on paper. They are fought in muddy fields and ruined cities, in workshops and factories, in the minds of engineers who must solve impossible problems with inadequate resources. The German advantages were real, but they assumed that war was a contest of existing capabilities rather than a race to develop new ones. They assumed that the British would fight with what they had on September 1st, 1939, rather than what they could build, borrow, improvise, or steal by June 1st, 1940. It was a reasonable assumption, based on historical patterns and logical analysis. It was also catastrophically wrong. The British did not fight the war the Germans expected. They changed the rules, discarded conventions, embraced unorthodoxy, and promoted every difficult bastard who demonstrated the ability to achieve results regardless of how many regulations they violated in the process. Percy Hobart was not unique in his brilliance or his abrasiveness. He was simply the most visible example of a type that existed throughout the British military and industrial establishment, experts who had been sidelined during peacetime because their ideas threatened comfortable assumptions, who were recalled when those comfortable assumptions collided with reality and shattered like glass. The epilogue to this story is written in the liberation of Europe, in the specialized armor that swam ashore on D-Day, in the thousands of modifications and adaptations that allowed Allied forces to overcome defensive positions that should have been impregnable. Each innovation traced back to the same fundamental insight, that military equipment was not sacred, that doctrine was provisional, that the only unforgivable sin was failing to adapt when circumstances changed. The tank built in 36 hours from scrap was not a triumph of engineering. Judged by conventional standards, it was a disaster. Uncomfortable, unreliable, poorly armed, inadequately armored. But it existed when it should not have, worked when it had no business working, and in doing so announced that the British would fight with whatever they could build, steal, or improvise, and that the Germans would face not just the army that existed, but the inexhaustible ingenuity of a nation that refused to accept defeat. That was the real weapon forged in that workshop during those sleepless hours, not a tank but a promise, that Britain would not surrender its fate to the efficient machines of its enemies, that every scrapyard and workshop would be mobilized, that the distance between civilian industry and military capability would be erased through sheer determination. On that frozen January night when Hobart's Folly rolled out of the workshop under its own power, grinding and smoking and barely holding together, it carried with it something more valuable than armor or guns. It carried proof that the war was not yet lost, that the advantage held by the German war machine was not insurmountable, that time could be bought and resistance could be organized if enough people refused to accept that impossibility was final. The senior officer from the War Office, watching that ugly improvised vehicle complete its test runs, understood that he was witnessing not just a technical achievement but a strategic shift. The question was no longer whether Britain could build enough tanks to match German production in conventional terms. The question was whether the Germans could destroy British industrial capacity, kill British engineers, and erase British knowledge faster than new solutions could be improvised from whatever materials remained. It was a race between destruction and adaptation, between the planned efficiency of a military designed for conquest and the chaotic resilience of a nation fighting for survival. In that contest, the advantage belonged to whichever side could learn faster, adapt quicker, and discard failed approaches with less hesitation. Germany had spent years perfecting its methods. Britain would spend the war inventing new ones. The difference between those approaches would ultimately determine which nation's tanks rolled through Berlin in 1945, and which nation's carefully planned doctrines lay buried beneath the rubble of a shattered Reich. The story of the tank built in 36 hours was never meant to inspire. It was meant to solve an immediate problem with whatever resources could be assembled. That it became symbolic was almost accidental, a side effect of demonstrating that the tools of modern warfare could be partially democratized if necessity demanded it. But symbols have power, and the power of Hobart's Folly lay in what it suggested to both friend and enemy, that the British would fight with whatever they had, would build whatever they needed, and would never accept that the superiority of German arms was decisive. The Germans had assumed they were fighting an army. They would discover they were fighting a culture, a history, a collective memory of improvisation and adaptation refined over centuries of global entanglement. That was an enemy that could not be defeated by superior tanks, because it would simply build different tanks, or stop using tanks altogether, and develop some other solution that the Germans had not anticipated and for which they had not prepared. The war would be won by production and resources and manpower, by American industrial might and Soviet blood and strategic bombing campaigns that erased German cities from existence. But it would also be won by 10,000 small moments like this one, in workshops and garages and makeshift factories, where skilled hands turned scrap into weapons and impossibility into mere difficulty. Percy Hobart, standing in the snow outside the workshop as dawn broke over the English Midlands, watched smoke rise from the improvised tank's exhaust and allowed himself a moment of satisfaction. Not pride, the vehicle was too crude for pride, but satisfaction at having proven once again that expertise and determination could achieve what regulations insisted was impossible. He had bought his nation 36 hours of progress, had added one more weapon to an arsenal that desperately needed every advantage it could scrape together. It was not enough, not nearly enough, but it was something, and something was infinitely better than the nothing they would have had if he had accepted that the task was impossible. That was the only truth that mattered in this moment, in this place, with the smell of burnt metal still hanging in the cold air, and his exhausted crew celebrating a victory that would never be recorded in any official history. They had refused to accept defeat. They had built a weapon from wreckage and will, and somewhere in the German high command, if they had known, the careful calculations about British weakness would have required revision, because the nation they intended to invade was not the one that existed in their intelligence reports. It was something more dangerous, more resilient, more capable of transformation than any planning document could capture. It was a nation that would build tanks from scrap in 36 hours if that's what survival required, and it would keep building and adapting and refusing to surrender until either the enemy was destroyed or there was nothing left to fight with. That was the promise forged in the workshop that night. That was the weapon that no intelligence service could quantify and no bombing campaign could destroy. That was why, despite the German advantages in men and machines and preparation, the outcome of the war was never as certain as the Panzers rolling through Poland had made it seem. Because on the other side of the Channel, in workshops scattered across an island nation, Difficult men like Percy Hobart were turning scrap into weapons and impossibility, into engineering challenges, and they would not stop until the war was won, or they were dead. And even death, they had decided, would not come easily.